All right, guys, welcome back to another KevCAM night class tonight. Tonight have Andrew helping out with any questions that come up along the way. Andrew, you with us?
Yeah, I'll answer those right away for you guys. What I mean answer, I'll read them out loud so Kevin can answer them for you. But what's up, guys?
And then, of course, we got Greg Payton helping out with on the technical side, so he can point out the blunt, obvious things that I'm missing for you guys. But okay, so kind of a spin-off of what
Hello, everybody.
Oh, sorry. Kind of a spin-off from what we've kind of been going off of the what's new in 2018. So tonight we're going to be covering the new, basically more than anything, the new turbo 3D mill that is built inside of HSM. We'll kind of go back and forth showing you examples of regular to the turbo and some more options that they added in there for you guys, but more importantly, how fast you can actually calculate a tool path. So, all right, I'll stop rambling here and let's get over to our part. Okay, so we got our part here. First thing I want to show you guys is they've added a new feature in the stock so you guys can actually do a castings without having to have a casting model. I guess what I mean by that is if I open up our stock here and you pick 3D model now, you can actually do a model offset. So this part was done in metric, so we got a 10 millimeter offset here of the part. So to kind of go along with that casting, we had a lot of customer requests to have that added in there. So now, let me just hop out of here real quick and I'll do a show. Maybe. There we go. So you can see we have an additional 10 millimeters all the way around our entire part to kind of serve as a purpose of the casting for you guys. So that's one new thing. It's not really new to HSM, but just kind of want to show you guys with the HSM side of things. Okay. One thing that actually Greg pointed out to me, and this will actually help you guys out with your calculations and more or less your solid verify, is your updated stock. Now this updated stock is you can turn this on and you can drag it down to wherever you want. But you got to remember when it's doing your updated stock here, it is also calculating behind the scenes for you guys to keep that updated stock calculated so you can click and drag that down where you guys want. So if you guys want to speed up things and make things a little bit faster as well, just right click on here and then turn off the automatic stock calculation. Okay, so we got a part here. We did a full 3D eye machining just to kind of get everything roughed out. And basically what I want to kind of show you guys is the difference between like constant Z and turbo constant Z. So we'll just start with constant Z first here. And we'll do 3D HSM. And we'll switch this. Oh, come on. Sorry, guys, I'm still running a dev build. Greg told me to stop running it, but I never listen.
You always got to be playing with fire over there.
Oh, yeah. Or ice water. For those of you guys that don't know, it's kind of inside joke. If you guys look in my the videos, I sank my snowmobile in the lake a few years ago.
Well, come on. What's the process like there? Are you like, you call it like the sheriff or something? Or like, how do you, is it just gone or what? I've never sunk a snowmobile, so.
You should try it sometime.
Yeah, I'll get right on it.
You got to hire a dive team to come down and yank it out within 30 days, or so the DNR starts finding you every single day that's in there.
Wow. Was it worth it?
Heck yeah, it was. What in the world is going on here? All right, I'm just going to kill everything. Not a good way to start out the class here. I just moved all my icons. There it is. Yeah, and a more interesting note, this weekend, I know this is just buying time here, but this weekend I was in a race and I got first place. First place in a donkey race. Got a trophy for getting bucked off the most amount of times.
Now, did they give you first place just because they were happy you didn't sink it in the lake?
Yeah.
It's like, where do you live? Just your stories are like, dang.
All right. Let's try this again here. Okay, so let's add milling, 3D HSM. I'm going to do my constant Z machining. And I'm going to use the same tool for all of these for you guys. So we'll use tool number 5, which is a 8 millimeter ball and mill. Constraint boundaries. So now for constant Z machining, I'm going to have to create a constraint boundary. And so I got one here. Let me just do a show. So I'm constraining it just to the outside perimeter. I don't need to machine anything on the outside currently. We'll leave it centered. And passes, we'll do a step down of, let's do 0.5 millimeter. And that should be good. Okay, so kind of keep an eye on how long this is taking to calculate here. Okay, so now we have our toolpath. Got some jumping around, some moving around and all that stuff. So now what I'm going to do is I'm actually going to create that exact same toolpath with Turbo HSM. So we'll do a constant Z. And I do have some new features in here as well. So what we have is an offset. So when we were talking about using HSS, you guys can actually do a drive surface offset. You can do that exact same thing with HSM now. So you can do a global or you can do a radial and axial offset. So for right now, we want to machine it right down to size. We'll grab that same end mill here, tool number 5. Levels, don't really have to worry much about those anymore. Constraint boundary, it's going to automatically find my boundary and keep it contained inside there. So now my constant depth is, I think we had 0.5 before. Now, let's do, oop, got that feed rate too high here. Oh, come on, 90,000, that's a little too high. Oops. Okay, so now watch how fast this calculates for you guys. All right, we're already done. So a huge time difference in going from Turbo HSM to standard HSM. Now my thought process going forward is they're going to get all of the HSM kind of switched over and migrated over to the Turbo. But for right now, what you guys have in here is constant Z linear, constant step over, pencil milling, constant Z rest finishing, and constant step over rest finishing. Now, since we are doing this in Turbo, let me just take it off. You can kind of see the toolpath. Still got some repositions in here, but got nice arc in. But the biggest thing that has come to our attention, especially with HSM, is I want to flip my start over. So instead of starting on the top and working my way down to the bottom, maybe I want to start at the bottom and work my way up. And that's kind of the same case with HSS. So you guys remember with HSS, you guys can actually flip that step over and change over what direction that goes for you guys. So you guys can now do that inside of your HSM. So right here we have flip step over, and I'll just minimize. So we have our starting point. I can pan this around for you guys here. So we got our starting point right here, and I can see our end point is right here. You guys are following my mouse cursor. So now if I want to flip that around, I can just do the flip step over. And now you'll see that we're starting right in that center and working our way to the outside. So a real nice feature in there. Now another big one that they've added in there, with the cutting path, you can now do spiral as an option as well, where before we only had zigzag or one way or bidirectional, or there was 4 different options: bidirectional or fill me in here, Greg. What am I missing? I'll just open it up here.
Are you talking about the passes themselves?
Yeah. No. Oh, here. So before we only had climb milling, conventional milling, bidirectional, or linked by level. So now with the turbo, you guys get more options with that as well. So we can do, a zigzag, or if we want to do one way, we can do one way, and then that will open up the climb, conventional, and then you can do same thing as HSS is the levels. So you can do by levels or by regions. And the difference is by regions is it's going to break everything up, so it's not jumping across the entire part. And it's just going to work on those specific regions as it wants. So switch that back to zigzag. Okay. So now we have our adaptive step down as well. This was also with HSM. That's going to add in additional steps. If I can cursor over it, you can see it's adding in additional steps on a more steeper curves to get a better finish for you guys. Not too much in the smoothing. Now in the link section is another big one that they added in there. So there's a lot of stuff that you guys are going to see from the HSS module carried over to the HSM. So now you have your links. So how do you want it to approach when you're doing short links and long links? So before you guys would have large gaps and small gaps. These are just set up as short links, and you guys can do shortest path. You can do a blend spline or retract to the clearance area. So a lot of these blend spline may be the best option, but it all depends on what kind of path you guys are trying to achieve. And then you can set up, what size of a gap it can be set to, or a value as well. Now on lead in, lead outs, just like HSS, we can add those in there. Like HSS as well, you have a default lead in, lead out, so you guys can set, a couple different options here. Not as many as what HSS has, but much better than what we had before for you guys. Another big one, we have full gouge check now for HSM. So if there's a certain surface that you guys don't want to touch, you can do that as a check surfaces, or we can do it against drive surfaces. And we have the ability to do 4 different gouges just like HSS. So if you want to do a gouge check against a holder on one, and maybe against a fixture on a gouge 2, do a drive surface on a gouge 3, and a check surface on a gouge 4. You guys have all these different strategies down here as well. Clearance, this is kind of carried over same as before for you guys. So the biggest thing I guess can take away from this is that we now have gouge check, we now have the ability to do better linking between our passes, but I would say the most is the cycle time, or the simulation time, just on how long it takes to calculate. So you're talking, I think they told us an exact number. Let's say it was like 4 times faster calculation. But you guys will notice when you guys, before when you guys were using HSM, HSM was supposed to be set to use all cores, but you guys might have seen that maybe only 4 of the 8 cores were getting, the full amount. Now it is utilizing all 64-bit for all the cores. So you should, when you see a save and calculate now, it should be pinging all of the cores that are related. Now it came up to me that, since we're a multi-core calculations inside SolidCAM, in SolidWorks they only use 1 core. If I have 32 cores, is my calculations going to be that much faster? Well, it reaches a certain point, and Anthony, our CTO, said, I think anything beyond 16 cores is not going to improve your performance, just because it's so many cores that it's trying to feed out to it simultaneously. Okay. Let's see. Just want to make sure I'm hitting all the highlights here.
Yeah, why don't you do a change on your HSM constant Z? Just a passes change. Change the step down a little bit on the normal constant Z, and show the calculation time there versus the change in turbo for a recalculation.
Okay, so if we just put this at 1 millimeter, save and calculate. About 3 seconds, would you say? And let's try 1 millimeter.
So what you can see on Kevin's screen is, with the old style HSM, it would have to go through the same amount of calculations as if you were setting up that pass from the beginning. Whereas with the new turbo, all that, or the majority of that information is already preloaded, so it's just handling the calculations for what has changed, which is why we're able to get calculation time so fast on a recalculation.
So I switched it up to 0.4 millimeters here, and you can see all the stuff that's kind of going on behind the scenes, even though that it, like Greg was saying, it already calculated a lot of that stuff. The only thing we're changing is our step down. Now, I'll hop over to the turbo here. 0.4. And Greg and I were doing some tests earlier, and it was like, well, did it calculate? Because it was so, we're not used to having calculation speeds this fast. So it's almost like you got to kind of check the toolpath. Like, oh, yep, it did calculate. So a lot of cool stuff here.
Yeah, zoom in on the toolpath lines and make sure that we're actually spreading out.
Yeah. All right. So let's do another one here. I'm going to turn off the toolpath here. And we'll add a milling, and we'll do a linear. So we'll do first 3D HSM. Do a linear machining. Tool select. We'll use that same tool here. And make sure you got that same boundary. Yep. Centered. Passes. We'll do 0.5 millimeter here. And there should be good. And you guys probably can't hear it, but I can hear my computer fan just booting up big time. Okay, so we got, a nice linear path on there. Covers up the part pretty nicely here. Got one retract move right here, but kind of starting over. Now let's do that same path with turbo.
Got a couple of questions here, Kevin.
Real quick.
Okay. One question, how much did that change the actual runtime? You might have already answered that. And then also, did you answer that already?
Yeah, so the runtime is not changed. The toolpath is not changed, except for some minor linking in here that is changed up. But you are going to get the exact same toolpath as what you've gotten before. It's just the calculation of the software is now 4 to 8 times faster.
Cool. Another question is, how is the stock accounted for between one op following another?
All because of the updated stock. Now, with HSM, it's not looking at the stock that's there. So if you guys are looking for just to base it off of updated stock, then you would do the rest machining. So rest standing for remaining stock that's left on there. And then what it would do is it would look at the previous operations that it was done and base it off of whatever's left over there. So hopefully that answers those questions. So let's do turbo again, and we'll do linear. Grab that same tool. Constraint boundaries, I can just leave it on automatic, and we'll do max step over as 0.5. And now with the linear, you guys actually have the option to do optimal machining in the XY. So what that's doing is, let me turn off that path. Let's just do calculation. Darn. So now we have our nice toolpath. Now this one's going a different direction. So if I wanted to match the exact same direction as before, I could come in here and go to my passes and actually put, a 0 in there and save and calculate. So our lines are going Y positive, Y negative. Now we should be going, our lines are going in the X positive and X negative. Now with this optimized machining, optimal machining angle is going to do is it's going to adapt for the surfaces. So what it's going to do is it's going to look at the surfaces and find the optimal angle to attack those surfaces at. So it's telling us going this way for the top. Trying to see here if our angles changed anywhere in here. I don't really see much of a difference with the optimize. It's all based off of the geometry that you guys have. So I guess you can kind of see a little swirl down here.
I think you may want to try that one again, Kevin.
What's that? Do the optimize?
Just try. Yeah, but maybe start this operation over.
Let's see. We'll go delete. Yes. Turbo. Linear. That dang feed rate.
Oh, it's going to stay.
Yeah, let's see a little bit of curvature going down this curve here, but not much. But like I said, it all depends on the geometry that you guys are cutting there. But when Greg mentioned that, reminded me of something here. With HSM now, you guys have the ability to do a feed control zone. So you guys can set up a zone of maybe anything inside of this pocket down here. I want it to do a feed rate of, 50 instead of 100, just for maybe a better surface finish and stuff like that. So definitely have the ability to do a feed control zone. You can set up multiple different zones. You can just draw a sketch in there, or you can take it off the geometry and chain everything up. So maybe everything on the flats that I need to have a better surface, I can just chain off all these areas, and it's actually going to change the feed rate of those. So you can see, I can offset, my boundary that I have there, but anything inside of that box, I want to contain it to, maybe 50% of the feed rate, and anything outside of the box, maybe I want to do 200% of the feed rate. So nice feature there. Plane height. So I'm trying to think, what else am I missing here?
Ronnie says, think those are surfaces, not chains.
Tool.
On the feed control zones.
Oh, yeah, you're right, Ronnie. Which makes it much easier to pick. So now I got all my flats. And I can say, like I said, 100%, and anything outside that, maybe 200%. Feed control zone is missing.
You can create solids in place wherever you want.
But I shouldn't have to create a solid just to do a feed zone here. I wonder if Ronnie's, if this is like that one part you were working on, Ronnie, where you had to add that additional surface in there. Let's do this. Well, here, I'll let Greg, do you want to look that up?
Yeah, I can look that up.
Then I want to keep going here so I don't run out of time. Okay, we'll get back to the feed control zone.
He was laughing. He said, no, the picture shows a cube.
Yeah, I know. And some of this HSM, it does some funky things, especially with the multi-axis. Is it a multi-axis roughing? I can't remember. One of the parts that Ronnie was working on, we had a whole surface body in there, but okay. Let's see. So we talked about the linking here. Talked about doing the flip step over. We talked about doing the adaptive step over. And the nice thing too is underneath the passes, it also gives you a scallop height as well. So you guys can see what kind of RA finish you'll be getting with that. Just trying to think here. You do have the ability to do start points now with HSM. So you can do a start point, and you can actually define a start point of where you want it to start. And one thing that they've added, I want to make sure I cover all the, so constant step over is going to be pretty much the same. We're going to have a couple more options in there. So if we go to passes here, passes, so you can actually do a cut order. You can start from the center, work your way from away or from outside to center, from top to bottom, or bottom to top. So you get a couple different options there with the constant step over. And you can also set that as a spiral too. So for this part right here, we can actually do a spiral, and it's just doing a constant step over of whatever you specify right here for you guys. Now, one thing that they added in there, if you guys still like to use the HSM after all this good stuff, is, let's say there's a lot in here for you guys, but Ron is saying, you know, I don't ever use boundary machining. I don't ever use morph machining. I don't want to see them in my list. Now you guys can come over to custom menu, and you guys can actually turn off certain ones in here that you don't use, so you guys don't have to see it all the time. So we can go like that, and now my list has gotten much smaller here. So if you guys want to customize this menu, not have so many different options in there, since maybe you guys don't use them very often, that's a way to kind of shorten that stuff up for you guys and make it more custom tailored to you guys as well. Just don't forget, if you're trying to find something in there, you can't find it. Could be because it's unchecked. So there you go, we got all our operations there.
Ronnie said he wasn't laughing at you. Sydney showed the volumes, I guess, last time. So trying the surface was a good idea. So
oh.
Ronnie wasn't picking on you.
Ronnie's always picking on me. All right, parallel cut, optimal based on geometry. Let's try doing, oops, let me get back into the turbo here. Linear. I'm surprised that optimal geometry didn't change the angle at all, but all is good. I think that covers everything. Did you find anything out on that feed control zone, Greg?
If you're using like an HSS pass, you can use surfaces like you had to find them. So it may be chalked up to your dev build there.
Oh, okay. Yeah, I forgot about that.
I think one more thing to kind of tie it to previous classes is these new HSM operations, and any HSM in general, can also be used if you're creating templates of these operations, if you want to use them in the drag and drop templates.
Yeah, great point. And how that goes about is you have your, let's say this is everything how you want it set up, hit the save template right here, and we'll just leave it as turbo linear target. And now you can see I have it over here in my template list, and I can drag and drop that right onto the part file. So great point. Or I can click and drag it from the tree onto the part. Hit OK. And looks like I'll just have to just do automatic. Oh, of course I picked the old one. But that drag and drop out of the tree works with all the operations as well. All right, guys.
Now for you dragging out of the tree, that's coming in a future spin.
Sorry, you broke up there for a second. What did you say, Greg?
Oh, I'm sorry. The drag and drop out of the tree is coming in a future service pack.
Yeah. Is that SP2? I can't remember what Sydney said on that one, out of the tree.
I believe so.
Coming
if
very
they don't
soon.
shoehorn it into a newer hotfix.
Yes, absolutely. All right. I just want to make sure I covered all my talking points for you guys to make sure you get a full class worth here. I think I got everything covered here. Do we have any other questions, guys? should open up my questions panel here and make sure I'm not missing anything. I love that when I'm not laughing at you, Ronnie. All right, guys, so that should wrap it up for tonight. So for let me see if Jack updated the class schedule here. Let me do a refresh, see if you got those added in there. No. So not next week. Sorry, I have to pull up the calendar here. So not next week, there will be no class, just because I'll be out of the office. But then the week after, we'll go over the what's new in the mill turn and the turning side of things. There's not a whole lot in there, more or less just with the setups and stuff like that. But there's some new features I want to show you guys in there. And then we're kind of getting back to the user choice. So let me just take a peek real quick. Let's see, the 14th, we are going to be having, today, must have forgot the 14th. So we got form tools being applied to parts. A big one was doing HSS undercuts with chamfers. Seems to be a big one. I think Ronnie, you brought that one up, and one of the other guys brought that up as well, as using like a lollipop cutter to drop straight down in the hole and do a undercut with a chamfer. I think that's the one on the 14th. And then got a part file that a customer wanted to see on kind of how Greg and I would attack that part file. So we're going to be doing some live programming for you guys right on the spot. So some good stuff coming forward for you guys. But the classes should update here within the next day, so you guys can sign up for those. But am I missing anything, guys?
No, I think you pretty well covered it.
Perfect. All right.
Sounds good, man.
Well, guys, thanks for attending the night class, and hopefully you guys got something out of it today with that the new Turbo 3D HSM. A lot of cool stuff in there, and going to save, especially if you guys are doing a lot of molds, a lot of that calculation time is going to be much, much faster for you guys. So I won't talk to you guys next week, like we said, but the week after we'll get the ball rolling again with the night classes. And if I don't talk to you guys in the meantime, have a great evening, and we'll talk to you guys later. Thanks, guys.